Let's talk a little bit about some of the uses of annotations. I find it pretty useful to understand how annotations are used in order to really understand this concept. Because until you know how this is going to be used, it doesn't really make sense. Why do we have this in Java? Why am I using this? I don't really understand something until I can see how it's practically applied. So the first usage of annotation that we're going to discuss is the compiler itself. Compilers frequently use annotations to do a lot of things in Java that help it to compile your code correctly or to treat certain code that's being compiled in a certain way. There's two good examples I'm going to give you here, and we're going to look at some more as we get into the code and see some of the usages of annotations. But one example is the suppress warnings that we had seen before. We can use this suppress warnings annotation to suppress some compiler warning that we would normally get. So let's say that we do something where we have some code that is not using generic, and we're assigning it to some code that is using generics. This would generate a compiler warning a lot of times, so we could use the suppress warnings annotation to prevent that warning from happening. In our example code, we had said suppress warnings deprecation, and deprecation is actually a annotation we can apply to some code, and it will cause the compiler to give us a warning when that code is used. We could suppress that warning with another annotation. We can also use an annotation to say that a method needs to be overridden. And when we use that annotation, we're giving the compiler a hint so that it will actually cause an error and not compile our code if it's actually not overriding something, but we've specified that we think this is overriding through the use of an annotation. So a compiler can use annotations to help compile the code, to help do things with warnings or errors, and to enforce some kind of contract about that code. It's a way to make your code a little bit more safe because you can enforce contracts before the code is running. So just like having a statically typed language allows you some benefit because the compiler can catch errors, you can use annotations to give the compiler some additional information about the code so it could catch even more errors or possible. Another major use of annotations is for tools. Tooling often uses annotations in order to do something useful with your code. One good example is a tool called JavaDoc, which is able to generate some documentation from annotations in your code. If you annotate your code using a special syntax, it can basically generate some documentation from those annotations. Some tools are even able to generate code from an annotation. So some good examples of this would be using annotations to basically create instructions how maybe some data is to be written to a database. If you annotate that data that's going to be written to a database in a certain way, you could then conceivably create a tool that could read those annotations and then create some code that would automatically be able to save that data to a database. Instead of having to write that code for each different type in your system, you could use annotations in that way. Annotations are also commonly used in a lot of testing frameworks like JUnit. Using an annotation like that, a tool could figure out what methods are intended to be test methods and figure out which methods to run. So it could basically invoke just those methods, and you could provide additional information about how the test is supposed to work, things of that nature. So tools is another major use of annotations, and once you're able to use annotations, you can really think of some neat ways to use those annotations within a tool, especially when you start getting into generating code or using those annotations to do something with your code. The final usage of annotations is in your actual runtime. In the actual code that you are running, you can use the annotation. And this is kind of a weird concept. This is what we're actually going to do in this module to demonstrate using an annotation. But some ideas here are things like serialization. We kind of already talked about this, but you could basically use your code, maybe in your program, you could read your own annotations on some of your data and then know how to serialize some of that data. If you're familiar with inversion of control containers, that can be done using annotations in Java. So you can basically use an annotation to help you figure out where to inject some dependency into your code. if you're not familiar with inversion of control, don't worry, it's not that complicated of a concept. The basic idea is it's a way to insert some kind of dependency into your code automatically. And using annotations, you could think about conceptually how that would work, how you could describe some data or some point in your code where you would want to use some dependency, and that annotation would provide a way for you to do that. Another common usage is an object relational mapping or object relational model. An annotation could help you to basically map from a database. We had kind of talked about this as well, but you could do this at runtime in your code. So you could automatically generate some code or use some generic code that is able to save any object to a database as long as it's annotated to tell some additional information of where it should go in the database. So when you use annotations like this, they can be really powerful in order to basically introspect about your code. So your code can do things with itself. It can examine itself and look for annotations, and then it can save you a lot of the scaffolding code, maybe repetitive code that you would have to write in order to do some common things, because instead of having code that handles every single type of data in your program, you might just have some code that's able to read annotations off of that data and then do something. So you're only writing that code one place, and it's adapting itself based on the annotations that you're using in your code somewhere else. And don't worry if this doesn't all make sense yet. It'll probably click a little bit more as we actually get into the code and see some usage of annotations. I just kind of want to give you this broad idea of what annotations are useful for and some of the things that you could do with the annotations once you know how to use them in Java. So let's look at some examples of actually using some of the built-in annotations in Java. I've got our Hello World program open here, and I cleared out some of the I/O stuff that we had done in the last module. I'll just continue clearing out the rest of this. And what we're going to go ahead and do here is we're going to use the already created annotations that exist in Java just to kind of demonstrate how annotations have been used. So some of these annotations we've actually used before. We actually use the override, but we're going to see how this is actually working, which we hadn't seen before. The first thing that we're going to look at, though, is this deprecated annotation. And we're going to deprecate one of our methods in our printer class. And what deprecate means is that a method should no longer be used. When we deprecate something, it shouldn't be used anymore because there's some better way, and maybe this is just being left there for compatibility, but you shouldn't use this class or method. So let's go into our printer, and we have this print colors method. And this print colors method was able to print out all the colors, red, blue, green, yellow, orange. But let's say that we don't want anyone calling this method anymore. We can add this @deprecated, and what this will do is you can see it's put a line through this method in Eclipse, and our compiler, since Eclipse is automatically compiling this code all the time, we're not seeing any kind of warning down here because it's already built it. But you can see here that we've got a warning. In the left-hand side here, this little light bulb here tells us that something is up with our code. And we can hover over this to see that we're getting a warning here. This method, print colors from printer color cartridge, is deprecated. And it offers us a way to fix it. We can also look at our problems tab here, and you can see that there's warnings here wherever this is used. We can see here that we have our deprecated warning right here. This method print colors from printer color cartridge is deprecated. So that's the basic usage of deprecated. And to use it, we just basically apply an annotation to this method, and that will make that entire method deprecated. The next one that we're going to look at here is one that we've already used called override. So if we look at our classes, we've got a class here that we had created, this color cartridge class, and you can see that we did some overrides here. We had overridden some methods, basically creating a new implementation for that method that overrides the base class's method, or this base interface's method. Now what override is doing for us in this case is it's giving the compiler some additional information. The compiler, when it compiles our code, is going to look at this override and say, I better check to make sure this method here is actually overriding something. And we can see how this works if we try to use override to override some method that's not actually being overridden. So I'll create a new method here called not overriding, and we'll just return an empty string from this. And you can see immediately I'm getting an error here. You can see this little red light here that's giving me an error. And it's saying the method not overriding of type color cartridge must override or implement a supertype method. So, and then it's also giving me in Eclipse some quick fixes to be able to do this. I could basically create this method in our iCartridge interface, and that would do it, or I can remove this override annotation, and so now this code would compile. So I want to point out here that this code is valid code. Adding this override doesn't make this code invalid. What it does is it tells the compiler, give us an error. Do not allow us to compile this code, because we've said that this method should be an overridden method. And so we're adding some additional information for the compiler to use. Before annotations existed in Java, you didn't have a way to specify this. So you might make a mistake. Let's say we had created a method toString. We had misspelled this. Without this override, we wouldn't get this error. But because we've added this annotation here, the compiler is able to tell us that we've made a mistake. The last thing that we're going to look at is suppress warnings. And this would actually allow us to ignore a compiler warning or prevent that warning from happening. And a lot of these annotations can be applied automatically. So let's go ahead and look at some of the warnings we have. We have 3 warnings here. We've got a warning that this method check copies is never used locally. We actually get a quick fix here in Eclipse to add a suppress warnings annotation unused to check copies. And now you can see here that when we do this, by adding this annotation suppress warnings and then specifying that it applies to unused, we end up not having this warning. So with this bit of code here, we're basically telling the compiler, yeah, I know that this is unused, but I don't want you to give me a warning because I know what I'm doing. I'm doing this for a specific reason. So those are the basic annotations that you can use that are built in Java, and these all happen to be annotations that the compiler uses. And you can see how this can really help you. It provides some additional information for the compiler in order to prevent you from making errors, to give you additional warnings about possible errors that you could be making, or to ignore some warnings that you don't always want to be bugged about by the compiler when you know what you're doing and you just don't want to. So once you start using annotations to enhance your code, to basically give the compiler some extra information about your code or other tools, other information, you're going to find that you're eventually going to need to create your own annotations. And this is really where the power of annotations is realized in Java, is when you can create your own annotations and then process those annotations in your code. So we're going to look at how to create an annotation in Java. So in our Hello World program, what we're going to go ahead and do here is we're going to create an annotation on our printer class, and we're going to make this annotation be able to tell us what the default print method is for the printer. This is something that you might want to do if you want to eventually have some code that can basically take any class that's a printer or can print and then examine that class and figure out what method to call on it in order to do some kind of a print. So we're going to create an annotation class that's going to allow us to decorate this printer and give some information about what method to call and what the default number of copies to print are. So we'll go ahead and go into our printing package here, and we'll do new, and we can just choose annotation here. And we'll call this printing device. And then you can see this is the way to declare an annotation. You basically just have this public @interface and then the name of the annotation. And you can see this declaration is very much like an interface. The only difference here really is this @. So we can declare some properties on this printing device or some fields to hold data. And we'll go ahead and create one of type string, and we'll call this default print method. So we just declare this just like you would declare a method in an interface. And then we can create another string here, or actually let's go ahead and create an integer that we'll call default number of copies. And what this will do is this will allow us to set these two data values on this printing device annotation when we declare our annotation. So we're going to specify the default print method and then the number of copies. So I'll go ahead and save this, and then let's go ahead and apply this to our printer class. So to do so, we just go into our printer class before our printer class, and we'll do @ and I'm going to hold down Control and hit space, and you can see right here printing device is an option. And then again, I'm going to hit Control and hit space to see, it'll auto-fill this in Eclipse to see what my options are. So for default print method, we're going to set this equal to, and let's choose the method here. We're going to do this print method. So we're going to take this text here so that when we actually use this annotation, we would be able to basically use the name that we're specifying here to invoke this method. And this is where we're going to get into the reflection. But for now, let's just look at how to create this annotation. So the default print method for this particular class is going to be print. And then the default number of copies, let's set this equal to 5. So by default, we'll print 5 copies. So there you have it. You have this new annotation we created called printing device, and it has a default print method and it has a default number of copies. And if we look at this declaration one more time, you can see it's just basically an interface with this @ sign. And right now, by default, this annotation is not going to exist at runtime. When we actually run our code, this annotation is going to disappear. We want to make this annotation permanent so it exists. The compiler keeps it around during runtime, and the way that we can do this is we can actually provide an annotation to our annotation. And we'll use this annotation called retention. So we'll do retention here, and then you can see here that we have different levels of retention, and we're going to choose retention policy of runtime. By doing this, it's going to make it so this annotation is going to exist on this class after our class is compiled, and that's going to be important for us to be able to access this metadata at runtime. And so now, when you think about it, this printer is going to have some additional information about it. This annotation is saying, about this class, I know that the default method is print, and the default number of copies are 5. And this doesn't seem very useful, except that if you think about having multiple classes, we could apply this annotation to, so let's say we had some other printer classes or some other classes that could do some kind of printing, but they had different methods and we didn't have a signature for them, or we didn't have control over how the methods were implemented. Then we could apply this annotation to all of these type of classes, and we could specify different print methods, different default number of copies, and then later we could look at these classes and know how to print with them, even though they might have different methods to call. So this isn't always the most efficient way to do this, but this kind of opens up the possibility of things that you can do